field due to a long straight conductor carrying current. For this, first let us consider a conductor. So this is a long straight conductor. This long straight conductor is carrying the current. That current is denoted by I. Okay, sorry, this is L and this gives a value of I. So we are considering a conductor. So this is a long straight conductor and this carries a current I. Now along this conductor we are going to consider a small element which is of length dl. Okay, so small element which is of length dl. Then P is a point at a distance a from O. Okay, so P is a point at a distance A from O. Next, here from A we are joining to P. That distance we are writing as R. Okay, so from A we are joining to P, that is written as R. Now if you measure the angles here, first we are writing with the value of theta. So A from this A we are measuring this angle, that angle is written as theta. So when you see here, this is a straight line. So in this straight line, if you measure this angle, so if this is a straight line and if you measure this angle, that is equal to what? 180 degree. Okay, that 180 can also be written as what? Pi, is not? So 180 can also be written as pi. Here also what we are going to do is, suppose if this value is written as theta, okay, and we know that this full angle is pi, and what happens to this value? This value can be written as this full angle minus this, is it not? Same way you are writing this angle to be pi minus theta. Okay, so we are writing as pi minus theta. So that is what is the value which you have written here. So this angle is pi minus theta. Okay, so then here we are writing as phi 1 and this side we are writing as phi 2. Okay, so these are all the angles. Here also let us measure this value to be phi. Okay, so this value we are measuring as phi. So these are all the basic ones in this diagram. Yes, clear with what are the terms we are taking? Yes, the main thing is we are considering with a long straight conductor, then we are considering with a point P, then this point P is at a distance A from the center O, and here is the point A, and this has a length of dl here. Then from A joining to P, and this angle we are writing as theta. Yes, and this angle we know that this value is equal to pi minus theta. Okay, and we are just joining from this and this point, and let us measure these values to be phi 1 and phi 2. Okay, so here is phi 1 and here the value is phi 2, and let us write this length to be L. Okay, so this length we are writing as L. So these are the terms which we have taken. So using this we are just going to see what happened, how we are going to derive the magnetic field. So as we know already, first is we are going to take with Biot-Savart law. So according to Biot-Savart law, what is the equation we have taken is dB is equal to, so for that first let us consider, so this is just about the diagram which we have seen already. So this is a diagram, is it not? So this is a long straight conductor and this is carrying the current I. P is a point at the distance A, then A is a point which is having the length dl. Okay, so consider long straight conductor Nm with the current I, then P be a point at the distance A. Next is consider an element of length dl which is at a distance L from the midpoint to R be the position vector and its length is dl. Okay, then as we know from Biot-Savart law, we are taking with the equation dB is equal to mu naught by 4 pi I dl sine theta by r square. Yes, next is, so mu naught I by 4 pi into I dl sine theta by r square. Then now taking the right angle triangle PAO. So first we are going to consider the triangle which is P, A and O. So in this triangle, considering with this angle, okay, so if you take with this triangle here, what is the value of tan theta? That is what we are going to write here. So I'm going to draw the triangle here. So if you draw the diagram, we'll get this value to be P, and this is O, and this is A, is it not? And here we have the value pi minus theta. Okay, so here we are having pi minus theta. So from this we are going to find what is the value of tan theta, is it not? So what is the formula for tan theta? Which is equal to opposite divided by adjacent, is it not? So the formula for tan theta, which is given by opposite divided by adjacent. Now when you consider the opposite side here, so what is the angle, what is the side which is opposite to this angle, which is OP. Okay, so we are writing as OP divided by adjacent side is what? OA. Okay, so which is equal to OP divided by OA. Okay, so OP divided by OA. Now what is the value of this OP is, as we have seen in the first diagram itself? OP is equal to what? A, and OA is equal to what? L, and so OP I am writing as A, OA I am writing as L. Now bring this L this side, and tan pi minus theta I am bringing down. Okay, so this L, if it goes this side, and tan pi minus theta if you are bringing down, you get L is equal to A divided by tan pi minus theta. Now this tan pi minus theta can also be written as minus of tan theta. So I am writing as minus tan theta alone. Now this A you can write separately. This you consider as 1 by tan theta. Okay, so this is 1 by tan theta. What is the value of 1 by tan theta is cot theta. Okay, now so we have got the value of cot theta. Same way we are going to find what is the value of r. Okay, taking with the next triangle. So what is the next triangle we take is the triangle which includes with the value of r. Now the same thing, but considering this to be a, this to be L, and this to be the value R. Okay, this gives the value R. Now with this same triangle, if you are going to take the value of sine theta, okay, so what is the formula for sine theta? Which is equal to opposite by hypotenuse. So opposite is A divided by hypotenuse is R. Now bring this R this side. So R is equal to A divided by sine theta. Okay, now we can write this A separately, and 1 by sine theta can be written as what? Cosecant. Okay, so we are getting the value of r to be equal to A into cosecant theta. So L is equal to minus A into cot theta, r is equal to A into cosecant theta. So from the same triangle, which is a small triangle, we got both the value of L as well as R, is not? So this value of L we are going to substitute here. This is a main equation. So we are going to substitute this value of R here. Same way L you are going to substitute here. Before substituting with the value of L here, what you have to do is we have to differentiate. So next step is we are going to differentiate with the value of L. Okay. First take with L. L is equal to minus A into cot theta, then R is equal to A into cosecant theta, as it is I am writing. Now differentiating with this, so I am going to differentiate cot theta. So if you differentiate cot theta, that is equal to minus cosecant square theta, okay, into d theta. Yes, so A as it is, cot theta if you differentiate you get the formula as minus. Already we have a minus here, so this becomes as plus cosecant square theta into d theta, because the cot theta is minus cosecant square theta. Clear? Substitute with the value of dl as well as the value of r here. So this r here it becomes as r square. So this you are going to square it, so this becomes as a square cosecant square theta. Okay, and this term as it is. Now one value of a and also this cosecant square theta. So here we are considering one value of a gets cancelled, then cosecant square theta fully gets cancelled, so we get mu naught I by 4 pi 1a, then sine theta into this d theta into dn. So here we'll not get with two values of d theta because only one value. Here you'll not get with this value. Okay, it is written wrongly. So because dl க்கு மட்டும் தான் என்ன பண்றோம், dl is equal to a into cosecant square theta into d theta. So அப்ப ஒரே ஒரு d theta தான் இங்க வரும். sin theta க்கு அப்புறம் ஒரு d theta வராது. ஓகேவா? Now the next, as we know from the diagram itself, the value of this moves from phi 1 to phi 2. Okay, the same way here also we are going to apply the limits from phi 1 to phi 2. Now if you apply the limits here, you will get this value as first integration of sin theta, that is equal to sin theta. If you integrate, that becomes as cos. Okay, so it is minus cos. So if you integrate sine, it is minus cos theta. Okay, now apply the limits in this. So what are all the limits is phi 1 and the upper limit is phi 2. So if you apply the limits, it becomes as minus cos phi 1, sorry, upper limit, so it is phi 2 minus, already we have a minus here, and in the formula it is upper limit minus lower limit, so it becomes as plus cos phi 1. Okay, so minus cos phi 2 and plus cos phi 1. So this I am just arranging and writing this as cos phi 1 minus cos phi 2. Okay, so this is the value which we have got for this magnetic field. Now using the same magnetic field, first when you are going to consider with a long straight conductor, we are going to apply the limit as phi 1 is equal to 0 and phi 2 is equal to pi. Okay, phi 1 வந்து 0 னும் phi 2 வந்து pi னும் substitute பண்ணா you'll get the value as mu naught I by 2 pi a into n cap. Okay, so this gives a magnetic field along a long straight conductor. Okay, thank you.